So here we are talking about AQA's paper 2. Paper 2 is the calculator paper, as you can see here, and this is a real paper taken from June 2017. And so this one is a paper that people actually sat in 2017. So the instructions, as per normal, just tell you to answer in black ink. So if I don't answer in black but I use highlighters, don't always do what I do, just do as I say. And definitely write your final answers in black. That's not to say don't use a highlighter or don't use pencils, but final answers should go in black. So without further ado, let's make a start and have a look at question 1. Which unit is most suitable for measuring the length of a tennis court? So there's 4 possible options here, and each possible option is at least a unit of length, so it's not dead easy, but hopefully should be fairly simple when you think about what we've got on offer. Kilometres are big. Kilometres are comparable to miles. So if I just put there, they relate to miles, because they do. So with kilometres you're talking about car journeys and such. So kilometres would be far too big really to measure a tennis court in. Centimetres, you're talking a ruler, something you could measure with a ruler. Now the average tennis court is quite a bit bigger than a ruler, and millimetres, very small indeed. You need 10 millimetres just to have 1 centimetre, and so that's something like an ant. Don't know why an ant sprung to mind, but something very, very small anyway. The only sensible option we've got would be metres. So metres being the most sensible, so this is the one we need to circle. It's essentially the unit that you don't need absolutely loads of, millions of, nor the unit where you need only a tiny, tiny fraction of one. So tennis court, about 10 metres or so. 10 metres, writing down 10 isn't going to break your hand. It's not going to confuse you with too many decimal points. So metres. Question 2. Circle the multiple of both 8 and 12. So multiple just means what numbers in both times tables. And so what we could do here is think of the 8 times table and also the 12 times table. So if I just highlight the 8s, and also we can have a look at the 12s. So the 8 times table and the 12 times table. The 8 goes 8, 16, 24, 32, and so on and so on, just adding 8 each time. And your 12 times table, just adding 12 each time. The next number would be 24, add another 12 would be 36, add another 12 would be 48, and so on. And so we need to stop when we can see a multiple which is in both, which is in one of these lists here. So far we've not got one, so we've got no choice but to carry on. So add another 8 onto 32, we'd get 40, 48, 56, this is where knowing your times tables can really help, 64, and 9 8s would be 72. But try and keep each times table in line, so the 8's got well ahead, try and make the 12s catch up. 48 plus 12 would be 60, add another 12 would be 72. So finally we found a number which is in both lists and which is one of our possible options, and so the one we circle would be 72. Next, what is 3 divided by 2 as a decimal? Well, the first thing to mention is that a fraction can be thought of as the top number divided by the bottom number. So if you know that half as a decimal is 0.5, 1/2 as a decimal is 0.5, then 3/2 would be 3 times 0.5. In terms of money, half a pound would be 50p. 3 times 50p would be £1.50, 1.5 pounds. So the one we need to circle is 1.5. Going back to what I was saying about a fraction being considered as the top number divided by the bottom number, you could think of it as £3 or just 3 divided by 2. I use money sometimes because we use money every day, so it lends a fairly easy context, one we can relate to. £3 shared equally between 2 people, it'd be £1.50 each. But because the trailing digit in the decimal is 0, we can forget the 0 at the end and just say it's 1.5. So either way, it's 1.5. Next, circle the correct statement. So I was always taught that the crocodile eats the bigger thing. So the open mouth needs to face the bigger number. And so if we have a look at these numbers, the crocodile needs to be facing the bigger one. Now, if you're talking about negatives, bigger means less negative. It would have to be this one, because -3 is less negative than -4, and so -3 is actually bigger than -4. If you think about it at the number line, if I just draw a line here, and imagine this as a number line. So I'm going to just put some numbers on here. So if you just imagine that we have, say, -6 here, one bigger is -5, one bigger -4, -3, -2, -1, 0. Then 1, 2, 3, 4, 5, and so on. So in terms of size of numbers, this end is bigger, and going the opposite way, going towards the negative end, the numbers would be going smaller. And so -3 lies more on the big side than -4, whereas looking at the others, -2 isn't bigger than -1 because -2 is to the left of -1. -6 sure isn't bigger than 5 because -6 is way down here, 5's all the way up here, and -1 isn't bigger than 0 because -1 is to the left of 0. It goes back to the fact that the crocodile will always eat the bigger number, so the open mouth of the inequality sign needs to be pointing to the bigger number, and the only one of the 4 options in which this holds true is the first one here. So that's why we'd circle -4, crocodile, -3. Question 5. Use your calculator to work out tick 701 as a decimal. Now, tick just means square root. As long as you're comfortable using your calculator, you shouldn't have any problems with this. It says write down your full calculator display, so just do what the calculator tells you. So I've got it here now, the calculator. So what we can do is press the square root button, which is this one here, but we type in 701 equals. Doesn't really seem to have done anything. This is what this S arrow D button's for. It converts from a standard form into a decimal or fraction form or otherwise. So if we press S arrow D, we get these numbers here. So we've got 26 Oh damn, my memory's terrible. I can't remember all those digits. Let's get it back. 0.476. What came next? 40459. And if you're lucky enough to have a calculator that shows even more digits, just write them all down. Do exactly as the question says. Write down the full calculator display. So don't do any thinking of your own. Don't do any rounding for this question. Just copy exactly what it says on the calculator. For 5b, we do need to have to do a bit of thinking because now it's asking it to be rounded to 1 decimal place. 1 decimal place just means in plain English we want to keep just one number after the dot. And so we know now that the answer is either going to be 26.4 or it's going to be 26.5. Is it going to be 0.4 or 0.5? The deciding digit is the digit immediately to the right of the one we're rounding. We're rounding to 1 decimal place. To the immediate right of a 4 is a 7. If a number is 5 or more, we round up. And so that 4 rounds up 1 to a 5. And so what we'd have here would be 26.5. Question 6. A swimming pool has 3 changing rooms, male, female and family. And we've got a pictogram with towels as a picture. Hope they're clean towels. Anyway, it shows the number of people using each changing room during 1 hour. We're told that 8 people use the male changing room. If we have a look at the male section, we've got 2 towels. So if 2 towels represent 8 people, in this case 8 men, then we can work out that just 1 towel must represent 4 people. And so we need to fill in the key by saying each towel represents 4 people. And then we're done for 6a. Part B of question 6, I'm just going to scroll down to show you. It says how many people used the female changing room. So just looking at the female changing room, we can just count up how many towels are in the female row. So the first towel represents 4. That represents 4. Each full towel represents 4 from part A. But here we've got 3/4 of a towel. 3/4 of 4 is 4. And if you're in any doubt, you can always just pull up the calculator, because it's a calculator paper after all, and just try it. So we've got 3/4 of a towel there. So fraction button. 3/4 of and multiply go together. So 3/4 of 4 is 3. And so this fraction of a towel represents 3 people. So in total, we've got 4 plus 4 plus 4 plus 3. So again, if it's a calculator paper, why not just use a calculator? If it seems lazy, then 2 things to say. It sort of is, but also I think you'd be daft not to use your calculator as much as possible, because it just gives you a way of avoiding any unnecessary little slips which could happen on non-calculator papers. So if in doubt, just use your calculator, because you can. 4 plus 4 plus 3 plus equals, we've got 15. So how many people used the female changing room? Our answer is 15 people did. Part C. The manager has brought lockers for the changing rooms. Why should she not use these results to decide where to put them? First of all, before you panic, look at the question. It's worth 1 mark, so it's not going to be overly complicated. So don't panic about it. Just think 1 mark, give 1 simple reason. So let's just go back to her results and see what might be wrong with them. First of all, swimming pools can be busy. If you look here, she's only got data for 8 men 15 women and 2 families, so it's not a very big sample of people she's using. Also as well, she's only recording this data for 1 hour. And so there's 2 main things you can say, and all you need to do is just say one of them. So one thing I'd suggest you might want to say is that the sample size of people is very small. Or another thing you might want to say, similar to that, is that the sample is only taken for 1 hour. Which isn't a long enough period of time. If you want to consider where to put lockers, you should really be thinking about getting data for a full day, a full week, maybe even a full month, because it's a serious decision. She can't just base it on 1 hour. Anything could happen in 1 hour. She needs a much better sample size than that. Question 7. We've got a list of numbers and we're asked to work out the median. The main thing when we're told about the median is median means middle. But we need to put them in order of size first. So start with the smallest. Smallest number is 17. So cross it off so you don't double count it. Put 17 down. The next smallest number, well, we've got 21, 21. 21 seems to be the smallest, but we've got 21 3 times. 1, 2, 3. And so we write down 21 3 times, each for every time it appeared. Now, after 21, we've got 23, and 25, 29, and finally 32 and 36. Now to find the middle one, we can just work in from end to end. It's not going to be the smallest or biggest, so we just work in from end to end until we get to our middle number. And lo and behold, the one in the middle, the one that's left, is 23. And so our median for this question is 23. Question 8, we've got a map of a town here, and it's asking us which place is exactly northwest of the station. So the station is here. We need to know the points of the compass. So north first, east, south, and west. Never eat shredded wheat. Or if you prefer elephants, naughty elephants squirt water. You need to know this really. And so northwest of the station means from the station, which is facing up and to the left of it. What we can do is superimpose this compass over the diagram, put it on top of the station, then just have a look which area of the map is looking northwest of the station. So northwest is this sort of general direction. So exactly northwest of the station, what would we hit? We'd run into the library. So the library is what is northwest of the station. And so what we need to do here is just circle that we're looking at the library. So it says circle your answer. I'm going to have to circle the library. And then we're done for part A. Part B, it says circle the 3-figure bearing of the monument from the park. So have a look here where the bearing's measured from, and it says from the park. Where bearings are measured from is important. So what we do is a straight line looking north from the park, and we're looking at the monument from the park. Now the monument from the park is actually just a straight line from the park going downwards, as so. And so as a bearing, what this would be is looking north from the park, how far we'd have to turn from the park facing north to face the monument. Now it's half a turn. From north looking south where the monument lies from the park is half a turn, and half a turn is 180 degrees. You can think of it as angles on a straight line. From north to south makes a straight line, and angles on a straight line add up to 180 degrees. And so what we need to circle for this one is 180. Question C, 8C. It now says about the distance in meters from the cinema to the station. Now we need to pay particular attention to the top right here, particularly where it says about the scale. So what we're told is that 1 centimetre represents 200 meters. So if we're measuring the distance in meters from the cinema to the station, we need to actually get a ruler out, like I have done here, and measure from the cinema to the station. Photocopying might vary depending on the settings your teachers used, but what you should find, roughly speaking, is that from the cinema to the station on your exam paper it should measure about 5.8. And so if 1 centimetre represents 200 meters, 5.8 would represent 5.8 times 200 meters. And so time to bust out the calculator. So get the calculator up and ready, and let's fire away. So what we have is 5.8 times 200 equals, and your answer should be in the region of 1160, or very close to 1160 meters. You will get method marks for writing your distance in centimeters multiplied by 200. So as long as you measure roughly correct, ideally exactly correctly, you'll get a method mark for this working line here. And the last part of 8 is 8D. Why might the shortest walking distance from the cinema to the station be greater than your answer to part C? It's a 1-mark question, so don't go off thinking on a crazy tangent. Be thinking simple. 1 mark, a fairly simple answer. So why might it be greater than the answer to part C? Well, what have we assumed for part C? What we've assumed is that we would go on an exact straight line from the cinema to the station. Now, very rarely, if ever in real life, is a distance between 2 places what you travel a straight line. Roads might zigzag or snake to the left and to the right, so it's never going to be a straight line, or if it is, it's incredibly rarely. And so your answer should be around the lines of, whoops, it's question 9. In real life, the distance travelled between 2 points may not be on an exact straight line. Or a statement to that effect. It might not be an exact straight line between where we travel from the cinema to the station. And that's all we need to say about that one, really. Question 9. We've got a bank statement. So we've got starting balance, council tax, and salary. So council tax is a debit, salary is credit. To put it simply, you just need to know about what debit means and what credit means. Credit, if you give someone credit, it's a good thing. they've done good. So credit is good, as is money going into an account. So credit just means money in, and debit, you can't spell debit without spelling debt. So it's the opposite as well. Just as it begins with DE, so does decrease. Credit is money going in, debit is decreasing your bank balance, so that's money going out. And balance is just what the money you have in your account right now. So starting balance is £212.48. A debit, council tax, think about it. Tax means money's going to be taken out. And so what we need to do, the new balance on the 14th of December will be £212.48, take away the council tax. And so using the calculator, we can type in £212.48, take away £128.39. Press the SROD button and we get £84.09p. And so that's what we need to fill in next. £84.09p. Then we have the salary. Now salary just means wage, essentially. So wage is money going into an account. And so what we do now is add in this amount here for the wage, which is £856.21. So we press equals, and what we'd have is 940.3. It doesn't mean £940 3 pence, it's £940.30, which is something completely different. And so those are the two amounts we need to work out and fill them in, 1 mark each. Question 10 now is a fraction based question. The average age of teachers at a school is 36 years. Mr. Smith's age is 11/9 of the average. How old is Mr. Smith? And so it's 11/9 as a fraction, but what's it a fraction of? It's a fraction of the average, and we've been told that the average is 36. And so what we're going to work out here is 11/9 of 36. Now, working out a fraction on a calculator, the of operates as a multiply, or shall I say the multiply works like of. So what we need to do here is we can use our fraction button, type in the fraction as it says, 11 on top, 9 on the bottom. Of implies multiply 36. And so how old is Mr. Smith? Press equals. Mr. Smith, bless him, is 44 years old. So we put in here that he's 44. Only about another 40 years to retirement. We now look on to question 11, which is the equation. Solve 4x minus 3 equals 14. I'm going to do this a few different ways. I'll start off by honouring Mr. Lawrence, my maths teacher. He would tell us the balancing way, which is essentially whatever you do to one side, we do to the other, with the ultimate goal of just getting x on its own. And so what we need to do here is get rid of that minus 3. Opposite of minus 3 is plus 3. So we can get rid of that minus 3 on this side by adding 3. But to balance this out, because equations, the left-hand side equals the right-hand side, so what we do to one side, we need to do to the other. So if we add 3 onto this side, we're going to have to add 3 onto the other side as well. So what that would give us is that 4x equals 14 plus 3, which is 17. Now we don't want 4x's, but actually we want to have just 1x. And so now what we need to think about is how do we go from 4x's down to just 1x's? What we need to do is divide by 4. 4x's divided by 4 would leave us with 1x, which is what we want. But if we divide the left by 4, what we need to do is also divide the right hand side by 4. And so x will be 17 divided by 4, which, since we can use a calculator, we can just type this in. 17 divided by 4. So we get, as a top-heavy fraction, 17 over 4, or we can have it as a decimal, which is 4.25. It really doesn't matter. So let's say it's 4.25. You could even, if you wanted, have it as a mixed number, which is 4 1/4. Now, if you want to know how to get your fraction to change it to a mixed number for you, if you press Shift and then the SAD button, SROD, lo and behold, 4 1/4, just like magic. And so x equals 4.25, or 4 1/4, or 17 over 4. You can take your pick. Now, taking what Mr. Lawrence used to do and making it much lazier, because I'm very lazy, is my method of doing it, which is just a bit more of a shorthand, really. And it's essentially whatever you do to one side, if you swap the side of something, you must swap the sign. And the way it works is because what's actually happening is because of what happened in the first method. So it's exactly the same question, just a different way of thinking it through. So again, we're aiming to get x on its own. You want to get rid of that minus 3, so get rid of it by chucking it to the other side of the equation. But if something swaps side, it swaps sign to the opposite thing. And the minute it's a minus, opposite of minus is plus. And so what we'd have there, on the left, the 4x is left on its own because the 3's moved away, but that minus 3 has become a plus 3, and on the other side, 14 add 3 is 17. And the same way, we want just x on its own, so we need to get rid of that 4. What's the 4 doing to the x? If there's no mathematical instruction between two different things, it will always mean one is multiplying the other. And so x is being multiplied by 4. The opposite of being multiplied is being divided. And so x equals 17 divided by 4, which, like we said before, is the same as 4.25, or you could say 4 1/4. Because equations are such good fun, I'm going to also show you one final method for doing the same question. All you need, really, is just one way of understanding it. So whichever way makes more sense to you, go with that way. But the final way you might want to use, if all the x's are on the same side of the equation, what you can do is use the flowchart diagram method. And what you do is you start with x. Start with a letter you're trying to find out. And then step by step, we just ask ourselves what happened to the letter. So x comes along. The first thing x encounters is the 4, which multiplies the x. And so x gets multiplied by 4. After it got multiplied by 4, we took away 3, and nothing else happened. That just all equaled 14. Now what we do is we rewind every single step, so we go back to the beginning, starting from the end. So we start at 14 and work backwards. We go the opposite way, doing the opposite things each time. Opposite of taking away 3 is add 3. Might want to make a note what 14 add 3 is. 14 add 3 is 17. And the final step, instead of multiplying by 4 that way, going the opposite way, we're going to be dividing by 4. So x will be 17 divided by 4, which, as I've said 2 times previously, is 4.25 as a decimal. Or, if you're in more of a mixed number mood, you could say 4 1/4. So x is 4 1/4, or if you fancy, x equals 4.25. Now we're on question 12. Lee sells ice creams. The table shows the midday temperature and his sales for 5 days. So some of these days are very hot. Hopefully we'll have some of these ourselves this summer. We'll see. So day 1, day 2, day 3, day 4, day 5, and sales for each day. But unfortunately, because Lee's been too busy eating ice creams by the looks of things, he's made 2 mistakes. So maybe fewer ice creams and more attention to his scattergraphs. Lee will probably never learn, but we can hope that he might. So write down 2 mistakes that Lee has made. So let's have a look what he may have made. Just check he's plotted the points right. So day 1, 30 degrees Celsius, 180 pounds of sales. So day 1, that's absolutely fine. Day 2, 26 degrees, which should be here, and 150 pounds of sales. That looks fine to me. Day 3 though, temperature should be 17, which is here, and the sales are 80. But when it's 17 degrees, he's put 60. And so what he's done is he's misplot for day 3. And so day 3 has been plotted incorrectly. Day 3 has been plotted incorrectly. And mistake 2, he's done a line of best fit, as he should have done. But if you have a look at the points he's got, the line of best fit shouldn't be really like that at all. It should be much steeper, because the trend of these points is more like something like this. And so his line of best fit really isn't anywhere close to how it should be. And so just something along the lines of, for mistake 2, his line of best fit is in the wrong place. His line of best fit is in the wrong place. It should be steeper, essentially. So that's the first part of the question done, part A. If we go forward onto part B, Lee wants to work out the range of the 5 temperatures. His calculation is 30 take away 20, which equals 10. Is his method correct? Slightly dubious question. His method might be correct. He might just be honestly mistaken. To work out the range, we do the highest take away the lowest. So the highest temperature is 30. 30 is the highest, and he's put 30, so that's okay. But the lowest temperature, it isn't 17. The lowest, sorry, it is 17, not 20. So the lowest temperature isn't 20, it's 17. And so is his method correct? Ultimately, no, it's not, because 20 isn't the lowest value. So he's misplotted points. He's not done the line of best fit right, and he's worked out the range incorrectly. I don't know if those are ice creams he's selling or vodka shots, but he needs to he needs to pay more attention. So 20 is not the lowest value. Lee's not having a good day. Maybe it's all this heat, because 30 degrees is pretty hot, so maybe we should cut him some slack. Anyway, question C, 12C. We've got a table of Lee's costs. Ice cream doesn't grow on trees, thankfully. You need ingredients to make ice cream and fuel to keep his van running, so he's got costs which are the ingredients, which are 15% of the sales. On top of that, his fuel is £7 per day. So work out his total profit. So what you need to know really is that profit, all it means is money made take away money spent. It's the difference between what you bring in and what you pay out. So the more money you bring in, the better. So the total profit for the 5 days. So first of all, we can work out his total income. So his total income is the grand total of all his sales. So if we have a look at all the sales he's got, it's all these values here. So his total income is going to be 150, or 180 first of all, plus 150, plus 80, plus 130, and finally plus 120. So we can do this on a calculator. In fact, we'd be pretty silly not to if it's a calculator paper. Just be careful. Use a calculator. 180 plus 150 plus 80 plus 130 plus 120 comes to £660. So his total income is £660. So I'm just going to put that highlighted. So his income, £660. What we need to work out now is his outgoings, the money he's spent. So he's spending money on two things, the ingredients and the fuel. So we've got a formula here for ingredients, the spend he's going to make on the ingredients. What he's spending on ingredients is going to be 15% of the sales. So it'll be 15% of 660. So again, may as well get the calculator to hand. 15%, the percent just means out of 100, so 15% means 15 over 100 of works as a multiplier. So multiply that by 660. Oops, not 666. That's a bit unintentionally evil there. Anyway, that comes to £99. So ingredients cost £99, but it's not just the ingredients, it's also fuel we need to factor in. So the fuel. Now we're told fuel is £7 a day. Just scrolling back up for a second, he's selling for 5 days. And so the fuel will be £7 multiplied by 5 because he's there for 5 days. So 7 times 5, use a calculator or don't, up to you, that's £35. So his total spend, what he spends, money going out, is what he spends on ingredients, which is £99, plus the £35 he spends on his fuel. So we add those together, 99, I've already got that, plus 35 comes to 134. So what he spent is 134. So we've worked out the total spend and we've worked out the total income too. So we're now in a position to work out the total profit. So his profit is his income minus his spend. Total of his incomings minus the total of his outgoings. So his income is £660 and what he spent is £134. So we do this on a calculator, 660 minus 134, and we end up with 526. And so our final answer is 526. 13. Work out the size of angle X. So you need to remember something about this one. And the thing you need to remember is about angles around a point. Angles around a point will add up to 360 degrees. So what I've got here is a right angle. Remember, right angles are denoted by a square. We also have other angles going around the point, plus of course the angle x, which is what we need to find out. And so just putting these bits together, we've got x, we've got 90, and we've got all the other angles. And because these angles converge at the same point here and go all the way around the point, they will all add up to 360 degrees. And so we can get an equation in terms of x. X plus 90 plus 36 plus 21 plus 160. Now we can neaten the equation up slightly. So we can work out what 90, 36, 21 and 160 all comes to. So we may as well do that now. And so if you look at this here, we've got 90 plus 36 plus 21 plus 160. And that all comes to 307. And so it's x plus 307 that equals 360. We want to have x on its own. We don't want that 307 next to it. And so what we need to do is subtract 307 from 360. So x will be 360, take away 307, which your calculator should tell you is 53 degrees. Question 14. We've got a conversion question asking us to change 70 kilograms into stones. So just in case you don't know this conversion off the top of your head, I don't think anyone does really, we've got some conversions here given to us, which is what you should expect really. 1 kilogram equals 2.2 pounds, and also we're told that 1 stone equals 14 pounds. So what we can do here is we can write out the conversions like this. So we've got kilograms and pounds like this. Now 1 kilogram is 2.2 pounds. If ever you have a relationship between two different amounts and one of the numbers is given as a 1, the other number is not a 1, to convert from one unit to the other, we know it will either be to times or divide by the number that isn't 1. So going from kilograms to pounds, what we're doing is we're multiplying by 2.2 because the pound number, 2.2, is bigger than the kilogram number, which is 1. So if we're going from a small to a big number, what we'll need to do is to multiply by 2.2. Going the other way around, going from pounds back to kilograms, we're going the opposite way, so it'll be the opposite process. So instead of multiplying by 2.2, it'll be dividing by 2.2. And we know it's 2.2 as a conversion factor because we're told that 1 kilogram equals 2.2 pounds. So what we need to do is change 70 kilograms into stones. So again, there's another conversion here, stones to pounds. So if we have stones at one side, pounds on the other, again, we're lucky enough to have this relationship in the form where one of the numbers is a 1, the other number is not 1. So once again, the conversion factor will be the number that isn't 1. So to change from stones to pounds, we're going from a small number, 1, to a bigger number, which is in pounds. And so what we're going to be doing there is multiplying by 14. And going the other way around, from pounds back to stones, going the opposite way, so it'll be the opposite process, which will be to divide by 14. And we're told this conversion factor in the question. 1 stone is 14 pounds. So that's where the numbers come from. So what we need to do first of all is to change the kilograms into pounds. And so to change from kilograms to pounds, we're going to multiply by 2.2. And so we get our calculator to the ready, and we've got 70 kilograms times by 2.2. So 70 multiplied by 2.2 equals 154 pounds. So first thing we need to write down is that, so we've got 70 times by 2.2, again using the fact that the conversion factor is 2.2, and that gives us, according to the calculator, 154 pounds. That's the first step. The second step is we need to change from pounds to stones. So if we're going from pounds to stones, we're going from a big number to a small number. So what we need to do there is divide by 14. So the next step is 154 divided by 14. So again, just to colour code, it's in green because I wrote this in green here, so that's where it comes from. So 154 divided by 14, again we can use our calculator, so why not? 154 divided by 14 equals 11 stone. So now we've worked out that 70 kilograms is 11 stone. So someone that weighs 70 kilograms weighs 11 stone, or somebody who weighs 11 stone, you can say they're 70 kilograms exactly. So that's question 15. Let's have a look at question 15. Question 14 is done now. So number 15, we've got some numbers here. Arithmetic progression, all that means is that the numbers are going up in equal amounts each time, either going up in equal amounts or going down in equal amounts. And so this one, 10, 15 and 20, the numbers are going up equally. They're increasing by 5 each time. The gaps are constant between each number in the sequence. We're now asked to use 3 numbers to make a different arithmetic progression. And so we've got some choices here. One thing we could do is we could pick 13, 20 and 27. That's one possible option. And we can do that because the gaps in between 13 and 20 and 20 and 27 are both 7. So the rule for this one would be just simply add 7 each time. Now that's one way you could do it. There is another way as well, so I'm just going to split the page down here. Another option we could use would be to have a look if there's any different numbers we could do, and in fact there is. We could also have done 15, 27 and 39. So instead of writing 13, 20 and 27, what you could have done is to have put 15, 27 and 39. Now that would have been an arithmetic progression in its own right, but would have been a different rule because the gaps are different. This time the gaps are going up in 12s, and so this rule would be to add 12 each time. I think the most obvious one is the first one, add 7 each time, 13, 20 and 27, but either would get you the full marks. So that one you've got 2 main options to go for. Question 16. A 1-mark question, but one you could easily get wrong if you're not careful. We've got counters in a bag, either red or blue. 1/5 of the counters are red. If 1/5 of the counters are red, that means the other 4/5 are blue. There's 5/5 in a whole thing. So to help with this one, I've done a diagram over here just to try and illustrate the point. And so what I've got here is a circle representing the counters. And so what I've got is that we've got 1/5 which are red, other 4/5 which are blue. So we have to work out the ratio of red to blue. So one slice of this is red. So one slice of red to 4 slices of blue. And so this one, the ratio of red to blue counters would be 1.4. A tempting answer is 1.5 because it mentions fifths. That's almost, dare I say, a trick question. It's not really a trick question, but it's very misleading. So just think, even if it's a 1-mark question, take your time, think about it, and return to it after the exam to see if you've got it right or you may have made a mistake. That one's 1.4. For every 1 red, there's 4 blue. Question 17. It says circle the fraction equal to 0.1%. Again, I think this one's down to just being comfortable and confident with your calculator. If you're good and well experienced with your own calculator, you should find this very easy. It's a 1-mark giveaway, really. So 0.1%, I'll show you 2 ways of doing it. Percentage means out of 100. So 0.1% is the same thing as saying it's 0.1 out of 100, because percentage means exactly that. So percent means out of 100. And so what we can do with these calculators is we can type it in and see what it says for us. So 0.1 out of 100, then we can press equals. And it gives us the answer straight away. So really, this one is easy once you know what you're doing. And so 0.1%, which means 0.1 out of 100, that's 1 out of 1,000. I did say I'd mention 2 ways. So another way is to use the percentage button itself, which lies just above the left bracket sign. So because it's in yellow, we do shift and the bracket. So the percentage we're talking about is 0.1. So 0.1 shift percent and press equals 0.1%, 1 over 1,000. So again, it tells us that it's 1 over 1,000. Once you know what you're doing with your calculator, it really does make it so much easier. Question 18. A 6-mark beastie of a question. Lots and lots of marks. So it might appear intimidating, but let's just do it one step at a time. So she works for a company that sells cars. So she must think she's really important. Her monthly pay is a salary of £1,470. 28% of the total profit the company makes from her sales, and a £250 bonus if she sells at least 15 cars. And so we need to just tackle this step by step without freaking out. Bear in mind, 6 marks for a question means you'd have at least 6 minutes to do it. You give yourself 6 or 7 minutes without feeling that you're wasting too much time. Aim for roughly 1 mark per minute, so 6 marks. We can afford to take our time with this one. So what we need to do first of all is work out, because it's asking in total for pay for the year, is work out what we can from a month to a year. So her salary is £1,470 a month. Well, there's 12 months in a year, and so what we need to do is multiply this by 12. So the salary is going to be 1,470 multiplied by 12. So I may as well use a calculator for this one. 1470 times 12. 17,640. So it's 17,640 a year. Also though, she gets a bonus and a percentage from the total profit she makes. So going back to the ice cream question from earlier, just remember what profit is. Profit basically means money you bring in, which in this case is going to be the income, minus money that goes out, which is the cost to the company. So just colour coding this one slightly. The income we're talking about, how much money she brings in, is this figure here. And the cost of the company, how much money she costs in doing her service, is this amount below. And so just doing this calculation, the income 538,000, take away 464,500, and then we can see what that equals. Just for doing this calculation, it's worth a mark. To do a 6-mark question, it's just picking up marks here, marks there. So 538,000 take away 464,500, which is 73,500. And her monthly pay is going to be 28% of the total profit she makes from her sales. And so 28% of that profit is going to be 28% of 73,500. We don't need to multiply by 12 though to change from months to years, because it says in the table just above it, the table shows information about the cars she sold last year. So these are already the totals for last year. So what we're going to work out here is 28% of the total profit, which we worked out from before was 73,500. So just reading the question here, we're just doing as the question says. So 28% of 73,500. Just remember what percentage means. Percentage means out of 100. So 28% is 28 over 100 multiplied by, whoops, need to go back. Yeah, it's easy as that to make mistakes. So 28 out of 100, then press away from your percentage. That's your percentage bit done. So it's that percentage multiplied by 73500. So again, use these buttons carefully with your calculator, as I just didn't there. And that equals £20,580. So £20,580. And so that's the percentage of the profit which gets added to her pay, 20,580. So just adding this bit on here as well. I think in a lovely blue colour this time, dark blue. So we've got 17,640 from earlier, and 20,580 from the percentage of the total profit. But also, we do know that she gets a bonus as well some months. She gets a bonus of £250 a month if she sells at least 15 cars. So how many months does she sell at least 15 cars? That's 3 months. And so she gets a bonus of £250 for 3 months of the year last year. So her bonuses she gets 3 bonuses of £250 each time, which is a total of £750. So her total pay for the year is going to be a combination of her basic salary, which was 17,640, plus the percentage of the percentage of the overall profit, which was 20,580. Plus, in addition to that, the £750, which was the bonus. So her total yearly pay is going to be all these amounts added together as one. So 17,640 plus 20,580 plus 750, and let's see about totals. So 17,640 plus we said it was 20,580 plus the bonuses, which amounted to £750, and the total pay for that year was £38,970. So the question is, was Ellen's pay for the year more than £40,000? So is this pay here more than £40,000? You need to conclude, ultimately it's a yes or no answer, and the answer is going to be no. 38,970 isn't more than 40,000, and so the final answer is to say no, it wasn't. You can't just guess yes or no and get 6 marks. That would be great if you could, but that would be just too easy. So it has to be based on each step of the working. So just take it one step at a time, work out what you can, see what new information you can generate from the information you're already given, and get as many marks as you can, and finally conclude with a yes or no. In this case, it's a no. Question 19. Ben and Katie throw darts at a target. Ben's ratio of hits to misses is 5 to 1. Katie's ratio of hits to misses is 3 to 1. Ben says 5 is bigger than 3, so I must have more hits than Katie. Give an example to show that this might not be true. It says give an example. There could be loads and loads, in fact infinitely many examples you could give. The key thing here is to realise that these ratios are simplified down. You need to be thinking of what could the actual numbers of actual hits to actual misses have been before the ratio ended up being simplified to these numbers. And so, although it seems like Ben's got a better hit ratio and In fact, he has. For every one miss, he hits 5 times as many as he misses, whereas Katie only hits 3 times as many as she misses. Just have a look at Katie's for a second. So it says here that Katie's ratio of hits to misses is 3 to 1. So just think about Katie. If we have on one side hits and misses, whoops, hits and misses, then it's simplified down to 3 and 1. But what could it have been before this ratio was simplified and ended up being 3 to 1? Well, for all we know, she could have actually had 10 times more hits. So 3 times 10, it's just any old example, would be 30. But if we multiply this side by 10, to keep the balance, we'd need to do the same to the other side. And so 1 multiplied by 10 would be 10. And so she might have had 30 hits and 10 misses. Now 30 hits and 10 misses would simplify down to 3.1, because we can divide both sides by 10, do the opposite thing to what we just did above. So it's possible that in terms of actual hits, Katie may have had 30 hits and 10 misses, which would still give her a ratio of 3.1. So Ben may have just thrown 6 darts. Ben could have thrown 6, had 5 hits, 1 miss, whereas Katie, for all we know, because all we're given is a simplified ratio, not the raw data, Katie might have actually had 30 hits and 10 misses. And so giving an example to show this might not be true, all we need to do is try and put this into words as best we can. And so if we can just write something along these lines and just put it down. So something like Ben may have thrown 6 darts and had 5 hits, whereas Katie may have thrown 30 hits and had 10 misses, because 30.10 would still simplify down to 3.1. So that's just one of a few examples you could give. So Ben may have only thrown 6 darts and had 5 hits, whereas Katie could have thrown 40 times in total, had 30 hits and 10 misses. So 30 hits is more than 5 hits, obviously. So any example along those lines. We could even say that Katie threw 4 million darts. Maybe Katie's very, very bored and got a lot of time on her hands. Maybe she threw 3 million which were hits and 1 million which were misses. So it's about just thinking the other way. Rather than simplifying down a ratio, you can also multiply it upwards too. Going on to question 20. A code has 4 digits. Each digit is a number from 0 to 9. It says digits may be repeated. The code starts 5, 4, 1. Joe chooses a number at random for the first digit. At random for the last digit. I need to get my eyes right. Write down the probability that he chooses the correct number. So we are told that each digit is a number from 0 to 9. And so I've wrote down at the bottom all the digits from 0 to 9 just to make it slightly more visual. The digits from 0 to 9, how many do we have? Well, we'd actually have 10 to choose from. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 isn't a digit, is it? You see, it's as easy as that to make a mistake and not think. But no, 10 isn't a digit. What I mean by that is 0. So, pardon me, allow me to correct myself. So for digits it could be a 1, 2, 3, 4, 5, 6, 7, 8, 9, or 0. So he chooses a number at random for the last digit. Write down the probability that he chooses the correct number. Knowing that the digits could be repeated, and there's 10 possible digits to choose from, then Joe would have to guess one correct number out of a total of 10 different guesses. So the probability that he chooses the correct number is 1 out of 10. Because there's only one digit which will be correct, and there's 10 possible different digits it could be. Part B of question 20. Again, the same code. Now Amy knows a bit more than he did. Amy knows that the last digit is odd, but not 7. So just thinking of the odd numbers are 1, 3, 5, 7, and 9. But Amy knows the last digit is odd, but not 7. So because it's not going to be 7, we can cross off 7 from the list. So how many odd numbers are left? The answer is you've got 4 odd numbers left, 1, 3, 5, and 9. And out of those 4, she needs to pick only one digit. So she's got one chance of picking it right out of a total of 4 different digits, 1, 3, 5, and 9. And so the probability that she chooses the correct number would be 1 out of 4, 1/4. Question 21. We're talking about Eva and her hygiene. She thinks she can save water by having a shower instead of a bath. So I'll get to the question in a second, but maybe Eva just shouldn't wash at all. That would save her the most water. Anyway, if she's going to wash herself, let's compare one against the other. So a shower versus bath. So I'm just going to divide up the page here. Shower on one side, bath on the other. I was only joking before. I do actually have a shower every week, every single week. So anyway, Eva's shower uses 10.8 litres per minute and it lasts for 8 minutes. So we can use that information to do a quick calculation. So 10.8 litres per minute lasting for 8 minutes, we can work out the total amount of water she uses in the shower. So it would be 10.8 multiplied by 8. And what does that equal? Let's ask Mrs. Calculator. So 10.8 multiplied by 8. 86.4 litres. Now we can compare that to the bath. So she assumes that the water in her bath is in the shape of this cuboid, which is 110 centimetres long, 50 centimetres wide, 35 centimetres high. And here we have a conversion from cm cubes, centimetres cubed, to litres. Now cm cubed, you should know really that this is a measure of volume. So we need to work out the volume of this cuboid. So the volume of a cuboid is the length multiplied by the width multiplied by the height. So the length is 110, the width is 50, and the height of it is 35. So 110 multiplied by 50 multiplied by 35. So 110, whoops, times 50 times 35 comes to 192,500. 192,500. Now this is volume in centimeters cubed. But what we need to do, we need to compare like for like. So here we've got litres for the shower. We could do with litres for the bath as well. Especially because the question's asking about how many litres. So litres is the currency we're interested in. So we've got a conversion factor here between centimetres cubed and litres. Now once again with this conversion factor, we've got that with this conversion factor, one of the numbers is 1, the litre number, and an other number which isn't 1. So because this one is in the form n dot dot 1, which just means that one number is not 1, the other number is 1, we can change from one unit to the other by either multiplying or dividing by the number which isn't 1. The number that isn't 1 here is 1,000. So to change from centimetres cubed to litres, we either need to times or divide by 1,000. Now 1,000 is the big number, 1 litre is a smaller number. So if we're going from cm cubed to litres, we're changing from a big number to a small number. So rather than times by 1,000, which should make the number big, we'll need to divide by 1,000. Going the other way around, not that we need to do it this time. If we were changing from litres to centimetres, going the opposite way, we'd be doing the opposite thing, which should be, to multiply by 1,000. And we know that because we're told it in the question. The conversion factor we're told effectively is 1,000. So one way or the other is either going to be timesing or dividing by 1,000. But what we need to do here, because we're changing from cm cubes to litres, we're going to need to divide by 1,000. And so we take our answer, which we just had a second ago, and divide that by 1,000, and we get 192.5 litres equals 192.5 litres. And so here we need to compare how many litres of water she saves, assuming that her assumption is correct. So a shower would use less than a bath, and so the water saved will be the difference between these two amounts. So the water she'd save would be 192.5 in the bath, subtract 86.4, which is what she'd use by having a shower. And so working out this calculation, 192.5 subtract 86.4, we'd get 106.1 litres. So she'd actually end up saving, according to this, 106.1 litres. Now it's hard to picture just how much that would be, but if you imagine a big bottle of Coke, not the ones you buy from a vending machine, but like a family bottle of Coke, it's 50 of those bottles. The amount of water she's saving would be 106 kilos, which is the weight of about 17 stone man. So that's a huge volume of water. So I guess the lesson here is have a shower instead of a bath. Anyway, moving on. Part B. We've got here for part B that we're just testing her assumption out. So part B, we're saying diagram A shows the water level before she gets into the bath, and B shows the cuboid in the empty bath. So the cuboid is from part A, which is what we based the calculations on in part A. So if you have a look at this, the cuboid is actually only a part of where the water comes up to. In actual fact, the water level takes up more volume than the cuboid does. So what that's saying is, her calculation for the cuboid as the volume of water she used in the bath wasn't actually enough. She actually uses even more water in the bath. And so what does this tell you about the amount of water saved? It tells us that because she'd used even more water than what we thought she used in the cuboid, because the water level's higher in actual fact, that even more water would be saved if she had a shower. So it tells us that the amount of water saved was more. More water was saved. Question 22. We've got a right-angled triangle. And it says to work out the value of x as a decimal. So if it's a right-angled triangle, you probably can guess it's going to be either Pythagoras or trigonometry. If you don't know it's one or the other, then you do need to know. Right-angled triangles is going to be usually, not always, it could be working out the area or something, but it could be either Pythagoras or trigonometry. Now, if we're asked to work out the lengths of sides, and we know the other two sides, it will be Pythagoras. So this one is Pythagoras. So when it doesn't involve any angles whatsoever, it won't be trigonometry. Trigonometry will always in some way involve an angle or wanting to find an angle. When we're not bothered about angles, we're only bothered about the sides, and we know two sides, we want to find a third, and it's a right-angled triangle, it'll be Pythagoras' theorem all the time. So work out the value of x as a decimal. So x is this side. The most important side you need to know for Pythagoras is the longest side, which is always opposite the right angle. So opposite the right angle here is this side, and that side is the hypotenuse. I'm just going to call it h. Your teacher might teach it different ways, which is fine. But the main thing here is that the hypotenuse squared, the longest side squared, is equal to the sum of the other small sides, both squared. So hypotenuse squared is the same as 3 squared plus x squared. The main thing is we've identified which is the longest side. The longest side is this one, which is the hypotenuse. But we also know the hypotenuse, which is quite good. The hypotenuse is 8, so we can substitute in 8 for h. So that means 8 squared equals 3 squared plus x squared. We want to know what x is. We're not interested in the 3 squared. So we can either work out the squares now, or we can leave them as they are. But, you know, let's just work them out, why not? 8 squared equals 64. And so this one over here is the same as 64. 3 squared, 3 times 3, which is 9, plus x squared. Again, to solve for x, we want the x on its own. So for the first step, we can get rid of this 9. If we chuck it to the other side, swap the side of it, swap the sign of it. So opposite of having 9 would be not to have 9. So if we do 64 take away 9, that will tell us what x squared is. So 64 take away 9 is 55. If in doubt, just use your calculator as your backup. 55. So 55 equals x squared. Now the opposite of x squared, to undo the square root, what we need to do, so to undo the square is called the square root. And so the next thing we need to do here is to do the square root of 55. And so x equals the square root of 55. So on your calculator, you can just get your calculator up, and quite handily, opposite the x squared key is the square root key. So these two go hand in hand, and your calculator reflects that fact. And so we type the tick first, and we type in the number we want to square root next. So press the tick symbol, which is square root, then 55, press equals, and then get it to a decimal. Now just round your decimal off to a sensible figure. If you're not sure, or the question doesn't say, as a general rule of thumb, we can round off to 3 significant figures. So 3 significant figures means the first 3 numbers which are non-zero. So 7, 4, 1. The 1 is next to the 6. The 6 is 5 or higher, which would make the 1 round up to a 2. So to 3 significant figures, that would be 7.42. If you're really not sure what to round it to, just write down the full figures of your calculator display. If in doubt, write it all out if you're not comfortable with the rounding, but it's 7.42 centimeters using Pythagoras' theorem. Question 23, we have a distance time graph of a journey. So Lily's going on a car journey. It says for the first 30 minutes her average speed is 40 miles per hour. So just thinking of the definition of miles per hour, 40 miles per hour means 40 miles in 1 hour. 40 miles in 1 hour. Now 1 hour is 60 minutes, so that means 40 miles in 60 minutes. But of course, according to this question, she's not actually travelling at that speed for an hour. She's only doing 30 minutes at that speed. So if she would do 40 miles in 60 minutes, but she's only travelling at that particular speed for 30 minutes, then she's not travelling at 40 miles per hour for the full hour. She's actually travelling for only half of an hour. So she only got half an hour to travel. She would only travel half of 40 miles. Half of 60 is 30, half of 40 would be 20. So she'd do 20 miles in the first 30 minutes. So the first 30 minutes, we can plot in here that she's going to do 20 miles. So using a straight line from 0 up to 30, and the y going up to 20. So that's the first bit of the journey. So the first 30 minutes, she's done 20 miles, which represents this part of the journey. Now you could, if you wanted, use a speed, distance, time triangle for this one. You wouldn't have to, but just if you wanted, just to recap what I mean by speed, distance, time triangle. Speed, distance and time. What you want to work out, you cover up. So for this one, we know the time she's travelling for, and we know her speed. We want to work out the distance. So the reason I'm avoiding using this triangle first off is because it's a mixture of hours and minutes, which can be awkward. But if you're comfortable with units, then the distance, cover up the distance, what we're left is s next to t. So distance would equal speed multiplied by time. Now speed multiplied by time. The speed she's going at is 40 miles an hour. Notice it's miles per hour. Now the time she's travelling for, keep the units consistent, keep the units the same. She's travelling for 30 minutes, which is half of an hour. So 40 miles per hour times half an hour, not that fraction, that wasn't meant to happen, you'd get 20 miles. So one way or the other, you'd get that she does 20 miles in that first 30 minutes. She then stops for 15 minutes. If she stops, she's not moving. So the distance travelled isn't going to increase or decrease. She's going to stay where she is. And so we're at 30 minutes already. In another 15 minutes, that'll take us from 30 up to 45. 30 plus 15 would take us to 45. And so the next bit, when she's not moving, would take us to that part of the graph. It'd be a straight horizontal line up to 45 minutes. It then says she completes the journey at an average speed of 60 miles per hour. The total journey time is 1 hour. So we're at 45 minutes currently. If she's going to finish at 60 miles per hour, then what we need to think about is how long she's going to be travelling at 60 miles an hour for. So she completes the journey at 60 miles per hour. So far, she's at 45 minutes. To get to an hour would be to 60 minutes. And so from 45 to 60 would be an extra 15 minutes. Now 60 miles an hour means 60 miles in 1 hour. Now 1 hour is 60 minutes. So 60 mph, 60 miles per hour, means 60 miles in 60 minutes. But she's taking 1 hour for the journey, so from 45 to 60, she's only got another 15 minutes to go until she reaches that hour. 60 miles an hour means 60 miles in 60 minutes. That's 1 mile for every minute. And so for 15 minutes at that speed, she'd cover 15 miles. And so what she'd do from 45 to 60 is her distance travelled would go up from 20 up a further 15 miles. 20 plus 15, that would take her to 35 miles travelled. And so the final bit of the graph would be to take us from 45 to a time of 60 and a distance of 35. And so the final portion of the graph looks like that. (23) Part B. We're asked to work out the average speed for the total journey. If I just return to the formula triangle from question A for a second, the speed, distance, time triangle. Here we are. Speed, distance and time. So if you want to work out the speed, it'd be the distance on top divided by the time on the bottom. So speed will equal distance divided by the time. Now, for such questions like this, for car journeys, the time will almost always be in hours in terms of speed. Kilometers per hour or miles per hour. The units of time will be in hours, as it was for question A. It mentioned miles per hour and 60 miles per hour. So the time we'll be interested in will be in hours. So because we're only interested for the total journey, we're only considering the total distance. And so if we have a look at the total distance travelled is 35 miles. 35 miles is the total distance travelled. And the total time, if we just drop a vertical down to the time, total time is 60 minutes. But of course we're not really interested in minutes, we would like hours. So distance divided by time. The distance, as we can see, is 35, and the time is 60 minutes, which should be 1 hour exactly. So distance divided by time, 35 divided by 1, any number divided by 1 stays as itself. So for the journey in total, it's 35 miles per hour. Only a 1 mark question, but just to make sure you understand where the answer comes from. Question 24 now is a question about a pie chart, and it's some information about voters in an election. So voters are either men or women. You need to know for this question how many degrees there are in a full circle. So there's 360 degrees in a full circle. So that's just worth writing down. 360 degrees is the full circle. We're told that 3,360 more women voted than men did. So just having a look at this question, the pie chart, if there's 360 degrees in the full circle and 110 degrees is what's represented by the men, all the rest will be for women. So all of this altogether will be 360. So the angle representing the women will be 360 subtract 110. And so 360 take away 110 is 250 degrees. So for women, the total angle is 250 degrees. Got a bit of information here comparing women to men. Is it says 3,360 more women than men. Not that 3,360 women voted, but 3,360 more women than men voted. So there's a big key difference there. And so what I'd suggest would be to compare the degrees for the women versus the degrees representing the men. So for women, 250 degrees. For men, 110 degrees. So how many more degrees is the women's section compared to the men's? So for women's is 140 degrees more. It's the difference between, so 250 take away 110 tells us the women's sector is 140 degrees more. So that's 140 degrees bigger. And we're told that 3,360 more women voted. And so that the amount by which this pie chart is bigger, 140 degrees bigger, will equate to how many more women voted. So this 140 extra degrees for the women's sector will relate exactly to the extra women that voted as compared to the men. So this is the subtle part. What you need to realise from these two bits of information is that that extra 140 degrees therefore represents 3,360 people. In this case, those people are women. So if 140 degrees is 3,360 people, what we could do is work out how much it would be for just 1 degree. To go from 140 degrees down to just 1 degree, we could divide by 140. Any number divided by itself gives 1. So 140 divided by 140 equals 1. But to keep the balance of this correct, if we divide one side by 140, we need to do the same to the other side. So 3,360 divided by 140 would tell us how many people each degree of this pie chart represents. And so 3,360 divided by 140 equals 24. And so that tells us that 1 degree represents 24 people. So each degree of a pie chart is representing 24 people. But obviously the full pie chart is the full circle, which is 360 degrees. So just going back to the original point, the full pie chart, which represents everybody, is 360. So ultimately we're not interested in 1 degree, we want the full 360. So to go from 1 degree to 360, what would we need to multiply by? Well, we'd need to multiply the 1 by 360. 1 times 360 would give us 360. But in the same way as what we did before, if we do something to one side, we need to perform the same multiplicative operation to the other side. And so 24 times 360, that will tell us the total number of voters represented by this total pie chart. And so 24 multiplied by 360 shows us that the total number of voters is 8,640. So the total number of people that voted is 8,640 people. So that's our final answer. Total number of voters is 8,640. Question 25. We've got a probability question based on CDs. We've got rock, pop and jazz. We're told that CD is chosen at random and that the probability of it being rock is 1 over 20. Now there are only 2 CDs that are rock, and so probability, as well as telling us the chance of something being picked, it also directly relates to the relative proportion of items in a set. And so because the probability of picking a rock CD is 1 out of 20, that means that 1/20th of the CDs must be rock, based on that piece of information. So we're told that there are 2 rock CDs, so 1/20th of the CDs, 1/20th of the total, equals 2 CDs. So I don't want 1/20th, I want the whole total. We want the whole total rather. So the total CDs, we need to think how many 20ths would make a whole. Well, 2 halves make a whole, 3/3, 4 quarters. In the same way, 20 20ths would make the full amount. And so we need to do 2 multiplied by 20. 2 times 20 is 40. So we've got 40 CDs altogether. But now we need to work out the probability that we've got a jazz CD. And so we're told here that the number of jazz CDs is 2x plus 5. Because we worked out that there's 48 CDs in total, 2 of which are rock, we can work out that the others must come to 38. And so we've got pop CDs here and jazz CDs here. And so because we've got 2 which are rock, 40 in total, that leaves 38 CDs still left. And so the other 38 CDs must be a combination of pop and jazz. these two added together must be 38 CDs, because 38 plus 2 would be 40. So pop, we've got x CDs, and jazz, we've got 2x plus 5. So what we've got here is an equation involving x. So what we need to do now is neaten this up and combine how many x's we have all together. We've got 1x here plus an extra 2x's. This would give us 3x's. Still plus 5, which equals 38. Now there are a few methods for solving equations, as long as you just choose a method which is right for you. I'm just going to use my sort of standard way of doing it, which should do the trick here. To solve an equation in terms of x, what we want to have is the x's on their own. So we need to get rid of the numbers first of all. So what we can do is we can move that plus 5 to the other side. But if we swap the side, we swap the sign. Opposite of plus 5 is minus 5. And so what we'd have here after that is that 3x equals 38 take away 5, which is 33. We can then do the same thing, same process for this 3. We want just 1x, not 3x's, just 1x. So what's that 3 doing to the x? If there's no mathematical instruction between two different things, it will always mean one is multiplying the other. So that 3 is multiplying the x. So if I move that 3 to the other side, swap the side, swap the sign, opposite of multiply is divide. And so what that tells us is that x is 33 divided by 3, which our calculator would tell us is 11. But what we're wanting here is a probability that a CD being picked would be jazz. So first of all, we need to work out how many jazz CDs would be in total. So we know from before, from the question, that the total number of jazz CDs is 2x plus 5. So 2x plus 5 is a total number of jazz CDs, but now we've just worked out what x is, we can substitute in this value for x. Because x is 11, as we've just worked out, 2x means 2 lots of x. Because x is 11, that's 2 lots of 11 plus 5. So the total number of jazz CDs is 27. Of course, the question isn't asking for just jazz CDs, it's for probability of picking a jazz CD out. And so finally, the probability of picking a jazz CD, well, the way we work out probability is it's the number of ways something can be chosen out of the total number of possible things that could be chosen. So because we've got 27 jazz CDs, and there's 40 things in total, 40 CDs in total, then the probability of picking jazz would be 27 over 40. And that's our final answer for question 25. Question 26. So we're now getting to the back of the exam paper, and the questions do get definitely trickier. This one, we've got a table of values for y equals x squared minus x minus 2. Now, it's not going to be a straight line graph, because here we've got an x squared term. Because of that x squared term, what it means is that we're going to actually have a quadratic graph. Quadratic graph, what it means is that it's going to be a curve. So we're going to have a curve, and because the highest power of x is an x squared, it's going to be called a parabola. So it's not going to be a straight line, it'll be a curve, and by parabola I mean it's going to look like this. It's going to look like a happy face. And because it's going to look like this, we can also say with absolute certainty that the graph will have symmetry. So the y values will repeat. What we've got here is two y values that repeat already. -2 and -2 repeat. So what will happen there is, either side going away from this place where they've repeated, there'll be a pattern here. These two will be the same, and also these two will be the same. So we've got a calculator, so we may as well put this to use. So what we can do is use a calculator for these values of x. So when x is 2, y equals x squared. So looking at the positive values first, positive is just easier to deal with. When x is 2, x squared would be 2 squared minus x, which is 2, minus 2, which would be 0. So when x is 2, y is 0. And we know as well that when x is -1, because these two values will mirror, y will be 0 as well. And when x is 3, y is 4, which will also mirror with this value here. Now, if you want to be a calculator geek or just know a few extra calculator tips, just bear with me for the next 2 minutes. Otherwise, you can switch off or skip ahead if you'd like. I'm going to explain how you can use your calculator, assuming it's a decent Casio like this one. I'm going to explain how you can work out the y values using your calculator. It's not easy, but it might help if you're willing to stick at it. What we do, we press the mode button and press 3 for table. It then comes up with f of x. Now that's what y is equal to. So just be thinking f of x, that just means y. So what we're going to type in now is the equation we're wanting. So it's x squared. So what we need to do now is find an x, which is here in red. So we press, because it's in red, as is alpha, we press alpha button, x, and the squared key, x squared, then it's minus an x, so alpha x minus 2. And we press equal, because we've typed in here the curve we want to sketch. So press equals. Now it says start. What it means is, where do we want x to start from? The lowest value of x we have is -2. So we don't want it to start from 1. We want x going from -2. So type in -2, then equals. Where do we want it to end? We want x to end at 3. So type in 3 and press equals. Step. What the step means is, what are the values of x we're using increasing by? X is going along 1 unit at a time. So x is stepping up by 1 number each time. 0 plus 1 is 1, plus 1 is 2, plus 1 is 3. So x is going up in ones. So let's leave it at 1 and press equals. Now what we're given here is a value of x's, and this column is y's. So what it says is, when x is -2, y is 4. When x is -1, y is 0, like we've already got. When x is 0, y is -2. So just scroll down further. When x is 1, y is -2. When x is 2, y is 0. And finally, when x is 3, y is 4. And you should also see these values of y being mirrored. So we go 4, 0, -2, -2, 0, 4. So if you want a bit more comfort, or you're not sure about how this mirror pattern works, with practice you can use your calculator, and it is a useful tip. Anyway, if you're happy enough with this mirror idea and can use the positive values to work out the negatives, then don't worry about it too much. Anyway, we've got 2 marks for doing that table. The next thing we're going to need to do is to plot the values in a graph. And so part B, we're going to use these values which I've plotted here. So you get a mark for just plotting the points. So -2, -2 would go here, then going up slightly at 0, and finally at 4. Now to get your final mark, and I don't like doing this because I'm pretty rubbish at it, as best as you can, this goes for me as well, as best as you can, do a smooth curve that joins each of these points together. And so don't take your pen off, that's pretty bad actually, and go up and along. You see I've missed that point there? Let's just go back, try it again. This is why a pencil comes in handy, you see. And then straight up. Now that looks a bit better. So that first one I did I make a mistake, or was I modelling something? Was it actually a metaphor I was making that if at first you don't succeed, try and try again? No, I'm not that clever, I just made a mistake. But anyway, that's why a pencil is useful. So question 26, plot your points, 1 mark, join them with a smooth curve, 2nd mark. Question 27, write these numbers in descending order. So descending means your numbers are going smaller. So highest first, down to smallest last. So your biggest number first, your smallest number last. So what you're best doing here is just working out directly what your numbers are. Well, 9563, that's just as it says. This one here, 9.56 times 10 cubed, that one's in standard form. So what we can do is just use a calculator to work out what this is. Now if you want to reset your calculator, I'll show you another tip. Shift, clear, CLR, clear all, press 3 for all, equals to confirm, reset all, press AC key. If you're wondering what I was doing there, that refers to the last question when I used my calculator to do a different function. Anyway, what we can do now is use a calculator to do 9.56 times 10 cubed. So 9.56 times 10 to the power 3. This is the general power button here, which you can use. So type in that one and a 3. We're going to get 9560. And so this one is 9560. And the one at the end here, 9.56 times 3 to the power 10, again, just use the calculator confidently and slowly, take your time, and just see what the calculator gives us. 9.56 multiplied by 3 to the power 10, press equals. Now that's a pretty massive number, 564,508-ish. So that's huge. 564, is it 508? I can't even remember 6 digits. Terrible. Yeah, so that's by far the biggest. So descending order, like I said, biggest number first, smallest number last. So 9.56 times 10, whoops, no, 9.56 times 3 to the power 10 is the biggest. The next biggest will be 9563. These two are very similar, but this one here is 3 higher than the one in the middle. So 9563. And the smallest number out of the 3 is 9.56 times 10 cubed. Question 28. Question 28. Rearrange this equation to make x the subject. Making x a subject, all that means is you want the equation written x first. Right here, y is a subject of this one. We want it to be x equals whatever x equals. So split the board into to show you two main ways you can do it. And so one way is just to have x on its own, just by doing swapping sides and swapping signs. So what we could do with this minus 9 is get rid of it and put it to the other side of the equal sign. But if it swaps over, it swaps sign. So the opposite of plus 9 would be to have minus 9. So the next step, we'd have y minus 9 equals x over 3. Then what we need to do is get rid of this 3. If a number's on the bottom of a fraction, it's dividing the top. And so x over 3 means that 3 is dividing the x. And so if we get rid of a 3, chuck it to the side, it will change from a division to the opposite of divide, which is multiply. Now, really important, this is the 3 going to multiply the 9 or the y? The answer is going to multiply everything on that side. And so what will happen is the y gets multiplied by 3, so we get 3y, and the minus 9 again gets multiplied by 3, so 9 times 3 is 27, not forgetting the minus sign, and then that equals x. Strictly speaking, that would only be 1 mark. If x is a subject, we need to write x equals first. So if we just flip the order that this is written and read it sort of back to front, x equals 3y minus 27. Alternatively, you could also leave it in factorized form, which would be 3 brackets y minus 9. And so either this way, x equals 3y minus 27, or x equals 3 brackets y minus 9. Just showing you a different method on this side. What we could do alternatively is start with what we're wanting to make the subject, which is x. And then we just ask step by step what happens to x. So x comes along, the first number it interacts with is this 3, which is dividing the x. So x, first of all, is divided by 3. After it gets divided by 3, we're going to add 9, and that's what y equals. Now we work backwards, so we go the opposite way and do the opposite processes. So we start with y and go back on ourselves. The opposite of adding 9 would be to take away 9, and the opposite of dividing by 3 is to times by 3, and that tells us what x would equal. So first of all, we take y, we take away 9, y take away 9 is that, and then all of this thing, all of whatever we've got in red, is multiplied by 3. So 3 times y is 3y minus, so put a minus, and 3 times 9 is 27. And so in a different way, we get the same thing. We get that x here equals 3y minus 27. But it needs to be written x first equals whatever x equals. So x equals 3y minus 27. Or alternatively, what we could do is just say it's 3 brackets y minus 9. So 2 ways of getting the same result there. Now we've got the last question. Question 29. The examiner's not been too harsh here. They've said use trigonometry to work out the value of x. If ever you think you might need to use trigonometry, or if it says to use trigonometry, almost as a knee-jerk reaction, almost like a Tourette's reaction, I want you to be thinking straight away, SOHCAHTOA. SOHCAHTOA. And these are the magic triangles which will definitely help you to work out a problem which is based on trigonometry. It's worth reminding you what the S, the O and the A mean. So just writing here, S means sin or sine of whatever angle we're talking about. C is cos. Cos is actually short for what's known as the cosine. So C is cos, again, of whatever angle we happen to be talking about. T means tan, which is short for tangent. T stands for tan of whatever angle we happen to be using. Now O, A and H relate to the sides of a triangle. So O is the opposite side. By opposite I mean the opposite side to the angle you're talking about. A is the adjacent side. And H, just like with Pythagoras, H is your hypotenuse. Hypotenuse is the longest side. What I'd suggest doing for trigonometry is finding your hypotenuse first. The hypotenuse is whatever side is opposite to the right angle, which is this side here, which is 8. And so H is the hypotenuse. So we can just put this into our triangle. So we know what H is. H is 8. We know what H is, which might be useful. So just highlight this in each one of these magic triangles. Now the opposite side is the side which is opposite to the angle we're talking about. The angle we've been given, apart from 90 degrees, but trigonometry can only be used for 90-degree angles. So the other angle we're interested in, the angle we've got here is 72, and opposite this angle is x, and so the opposite side is x. And so opposite is what we're interested in, because we want to find out x, which is the opposite. And so we want to work out x, which is the opposite. I think the adjacent is best thinking of whichever is the odd side out. Work out the hypotenuse, work out which is the opposite. The one you've not worked out is just the spare one, which is the adjacent. Now we've not been asked to find the adjacent, and we've not been told it. So we don't know the adjacent, and we don't want to know it, so we don't really care. So any triangle with A in, we're not too bothered about. Which of these triangles tells us the most information? So you need to be looking at which triangle uses what we know, which is the H, and what you want to know, which is the X. The triangle which tells us what we want to know and what we already know is this SO triangle. So we're going to use SO. So we're going to use the sin triangle. We're wanting to work out the opposite. So what we do is we cover up the opposite and just look what's left. So put your hand over the top of a triangle. What you've got left is S and H together. So what that means is the opposite is S and H next to each other. Now in algebra, if you've got two things next to each other with no instruction telling you what to do with them, you always know to times them together. So the opposite side is S times H. Just going back to what I mentioned before, S stands for sin of the angle we're mentioning, which is sin 72. And H is the hypotenuse, which we know is 8. So the hypotenuse is 8. And that will tell us what the opposite side is. The opposite side being x, which is what we wanted to know all along. So the opposite side is sin 72 times 8. So there's nothing more to do now apart from just to use our calculator to work out what this is. So we get the calculator up and ready. And what we need to do now is sin 72 times by h. I'll just move the calculator across. Never mind, I'll leave it there. So we do sin, be careful with the brackets. So sin 72, close brackets, multiplied by 8. Remember, sin 72 times 8, so the calculator needs to reflect exactly what we've written down. We then press equals. And what we'd get is 7.608. Now, it doesn't say how accurate to give the answer for this one. If in doubt, you can use either 3 significant figures or even 1 decimal place. But for this one, as I've said before, if you're not sure, just round off to 3 significant figures. And so, writing down what this one is, it's 7.6, but next to the 6 is a 0. So it's either going to be 7.60 or 7.61 if that 0 rounds up. Next to the 0 on the right is an 8. Because 8 is 5 or more, that 0 will round up 1. So 0 goes 1 higher to 1. So to 3 significant figures, we've got that the opposite side, x equals 7.61 centimetres. And that's correct to 3 significant figures. And that completes paper 2. So that's paper 2 of June 2017 done. Feel free to look through the questions again, or feel free to email me for any other suggestions, or if you've struggled still with any of the questions. So any feedback's welcome, and thank you for listening.